What's up, everybody? Welcome to Tesla Fix. Today we have a very special episode about FSD and the Tesla bot. And we had the shareholder meeting last week or this week. And that's why I've invited Dr. Know-It-All, John Gibbs, and Scott Walter to discuss these amazing topics. Say hello, everybody, to the audience. I'm glad you're here.
Yes, schönen guten Tag.
Again, Scott with his German, because he lived in Germany a few months or years at least.
Years,
I'm not
yeah.
sure. Years, exactly.
Years, yep. Mm-hmm.
Yeah, and and today How was the shareholder meeting? I mean, it was super exciting, right? Maybe you can just talk a little bit, all of you, what your thoughts were. Maybe we start with John, and then Scott can also tell his view.
I guess it's a very poorly kept secret that I got to ask a question during the meeting. So that was kind of a highlight for me, obviously. But I think the takeaway for me was it's all about, I don't know what to call it anymore, because they need to rebadge it, but it's not full self-driving anymore because Optimus is using it too, but full self-robotics, full autonomous robotics. Maybe we could call it FAR, full autonomous robotics. But whatever that thing is, that architecture is the big takeaway for me. And obviously I have a very high bias towards that, but come on, Elon walked out with the little love robot shirt, and it was all about the robots. I think Scott says that too. So I'll let Scott.
Yeah. So, of course, John was in person. I was at home watching the stream along with everyone else. And the first thing I noticed is it's about the bots, because the first, the t-shirt said everything. And I looked back in some of the previous presentations that Elon's been at, like Investor Day and the last Shareholder Day, which are kind of, let's say, neutral events as far as what you're highlighting. It's not, about the batteries. It's not about the AI. So he comes out to a shareholder meeting wearing that. It's like, that's setting the tone. And of course, they didn't really talk about it until the very end. And that's the only video you sort of see. And it tells me it really, and of course, he then went on about how important the bots are going to be to the Tesla story. He says long term, it's going to be all about the bots. So if you weren't paying attention, it's about the bots.
I think it's also worth noting the contrast between this and Investor Day, which was March 4th, something like that.
Anyway, around March 4th.
About 2.5 months ago. And remember the Optimus video that was put into there that felt really, really herky-jerky, like nobody was expecting it. They just sort of threw it in. This entire Elon speech felt like it was that was the target of it. So this one was clearly arranged. And I know that the poor people who had to do the video were up all night, because he said that, that they were working really hard at the 11th hour to get the video out and make it look really good, high quality, so that he had something to, show while he was talking. But I think his entire speech was oriented towards that, which was super, super cool to see.
Yeah. I also agree that for me, at least, even if everybody's talking about the cars all the time, and especially Wall Street really loves just to talk about the cars, and Tesla's just a car business, and to view it out of this lens. But I think it's very evident right now that if you see the developments of the robot, and I've discussed this very thoroughly with Scott last time, that's why I'm very excited for the bot, because this will show that Tesla can put its brain of FSD or the system, this vision-based system, into everything. They could program a lawnmower if they wanted. So it doesn't matter. If they crack full, real life vision is such a big deal that I can't even put a number on this. I mean, I'm not a financial expert, but I think the valuation is pretty low at this point if you compare it to this huge ETF that Tesla is. So
let's all hope so, right? Any investor.
And that's why I've wanted to at first, maybe we can start the episode here with looking at the question you've asked, John, on the shareholder meeting, and let's just dive into FSD a little bit. maybe we can talk about the developments that are until now and the horizon, what we might expect. We all can discuss this topic, and then we're going to shift to the Tesla bot, because this is the brain of the Tesla bot. So pretty interesting stuff. We're going to start with the clip that I've taken out of the shareholder meeting here.
I'm John, or Dr. Know-It-All on YouTube, and I don't know it all. But anyway, my question is, as you guys move completely or finish the transition in full self-driving from version 1.0 of the software to 2.0, what do you perceive of as the potential stumbling blocks after that? Because it seems like that's the major, kind of step change that needed to happen, and so you're almost done with that, and what happens after that? And also, please let me interview about full self-driving. I'll spend 2 hours talking to you about just that. So, thank you.
Well, one can really think about full self-driving as sort of a march of nines of reliability. So we need to get to the point where the probability of injury is lower than that of the average human driver, and then ultimately probability of injury is much lower. So even at the point at which the car is capable of driving itself, there's still actually a lot of work to do, because every year there's 1 million people that die in auto accidents, and I think probably everyone in this audience has friends and family that have died or been seriously injured in auto accidents, and for there's 1 million people that die. There's 10 million people roughly that are seriously permanently injured. And so it matters that if we can get that down by an order of magnitude, there's 900,000 lives saved per year, maybe 9 million severe injuries prevented per year, and so that really, I think, morally has to be our primary goal. I guess I'm open to an interview on FSD. 2 hours is a long time, but okay. All right, I'll do an interview. It's got to be on Twitter, but sure. All right.
So pretty awesome stuff that he said, and maybe you can comment on this video, John. What you think? I mean, he really highlighted the safety of FSD and why it's important. A little bit more on the mission of FSD. But maybe how was it? You were really nervous. I can't imagine from the inside. I mean, you seemed very calm, but
thank you.
Great thing you did it.
So here was the thing. It was the person who had the microphone just happened to be at the end of my row, and I think Scott remembers at AI Day. At AI Day, we were ahead of the row where the guy was. So by the time we could have gotten in line, you would have been 30 people back, and you never would have had a question. So I just managed to sneak out right behind Mark, who was the guy who dresses in the Tesla bot costume. So he asked a question before me. He said, anyway, but. So I didn't actually have a question. I texted Scott while I was standing there. I got up and I said, Scott, I need a question to ask. And he's like, what? So, anyway, so I'm standing there and everybody else had notes and they had written down questions and I had nothing. So I was in my mind while everybody else was asking their questions. I was like, okay, come up with a question, refine it. Don't forget. That was the thing I was terrified of. And my heart was it was worse than being in a marathon or something. My heart was pounding out of my chest when I asked the question. I think it was less about Elon, and more about the fact that there was I had a microphone with over 1,000 people in a room where I'm asking a question. It's pretty terrifying to do that in any circumstance, much less when you have a live stream. So yeah, it was very scary. And I hope I came across sounding reasonable, but the most important part was Elon's answer to the question. And I think I asked the question a little bit poorly because I was asking him specifically about what Andre Karpathy talks about as software 1.0, which is more traditional coding, loops, if-then statements, things like that, moving everything to the new neural network architecture. And he didn't answer that question directly. And listening to my question, I realized I didn't ask it as well as I could have, whatever. But what he was talking about is the fact that this is something that's it's a journey. It's never a destination. So 5 or 10 years from now, these computers, these machines could be driving way, way, way safer, 100 times, 1,000 times safer than a human can, but there's always still room to get another 9. You can always go further. And I think that was the kind of gist of his answer was it's there's never any benchmark that you can hit and it's going to automatically be better and we can stop working on it. It's always, can we do a little bit better and a little bit better and get this weird little corner case that only 3 times has happened in the world, but we still haven't even approached the driving in someplace like India or Nepal or places like that where the traffic is absolutely chaotic. So there's always going to be room for it to improve, but at the same time, he's pretty convinced that by the end of this year, it's in at least in the United States and Canada where it's been trained, it's going to be provably better than the average human. I do have a caveat to that we can talk about in just a minute, but I'll let Scott, because I can tell you want to say something too.
Oh, no, it's like, I was surprised when suddenly I get this text from John that says he's in line. I'm like, yeah, right. He's probably back like 20 people. The questions that I'm going to give is not going to be important. He's never going to ask it. And then I send it the next thing I look there. Whoa, John. It's like, holy cow, how did you get asked the question so quickly? And of course, the other thing is that we did not coordinate this, but I thought the appropriate T-shirt today would be this. And the problem with this T-shirt, it's an inside joke that even people in Tesla don't get the joke, and even Tesla owners don't get it. I have to explain it, so it's a really bad joke. But as you know, ego is what they refer to the car. That I think it's a AI term of art of some sort, right? That you're always referring to, ego makes this decision, that decision. So yeah, again, if you have to explain the joke, it's not very fun.
Right. I want to make a point. This is on my merch store, so if people want to go get it, they can. But Dan has updated it with the fat noodle now. So instead of the old OG version that has the skinny noodle, it's got the fat noodle now. So if you order one, you get the up-to-date version. Yeah.
Okay. Yeah. So I'm gonna link the merch store in the description below, and maybe when my channel grows someday, I'm gonna have merch too. I'm because I'm a designer. I'm waiting for this to happen. I have some things lined up already, but it's too early to do it. But I'm gonna do it.
Just put it up there online. People will buy it.
Okay. All right. I'm gonna do it. But please, Scott, go on. So I really wanted to know what you thoughts on FSD or the state of FSD is. It's pretty interesting for me too.
Yeah, it's John is more the expert in that. I mean, from my standpoint, I have been using FSD and I see it is improving, and it seems to be doing things a lot smoother. So the area that I drive around with, I have to deal with a lot of pedestrians and cyclists all the time, especially on weekends. It's a very popular area for cyclists, and the road is set up that you can have streams of cyclists going in both directions. It's like the Tour de France almost. And so I'm very careful getting out and going along there. And it used to be, you almost got up to the cyclist before it decided to give the cyclist maybe another, 100 centimeters of clearance. It's like, no, that I don't like that. And now with the more recent versions, it anticipates way in advance when it sees any sort of cyclist and will go out and it will go over the midline. So, it's just something we would do, even though you say, well, you want to just go up to do it and not. So before, I think it would stop at the yellow line. Now it will actually go over if there's room. And I even noticed it would play chicken a little bit with oncoming traffic that's coming the other way and wait for the oncoming traffic also to give a little bit of room before it came back in. So it's like, that's usually how it is. And then I had one situation where I was approaching a cyclist and there was a car coming the other way, and I was about to disengage when suddenly it backed off on the speed, and then waited for the car to go past, and then went back up to the speed and went back on over. And to me, it's like, that was exactly the way I was going to do that maneuver. It was very human-like to me. The only thing that's missing is to get a little bit more of this idea of it understanding objects better, which I know they're trying to do with pedestrians trying to do crosswalks and everything else. But so I have the problem is that there's bikes coming the other direction as well, right? And there's cars coming the other direction. And when I notice that situation, if there's no cyclist on my side, I will get over to give the cars room to get over. And it's not doing that yet. So, I mean, it still is like, nope, this is my lane. I'm staying in there. And those other cars are going to have to slow down and wait for me to go by. So if FSD starts doing that, then I will be really, really impressed. And there's still some disengagements in areas that need to be fixed, but I am definitely seeing improvement. I'm a lot more confident. I've had a lot more rides where I've engaged it, had an occupant in there. We've been chatting away, and I realized, oh my God, we made it all the way to destination without a disengagement, and I wasn't worried at all. So sometimes what you actually need is a passenger that kind of distracts you enough that you're not so worried about what's it about to do. And it seems like if everything is fine, you go ahead. And it's
so
really close to the wife test now.
It is. Yeah. We should be a little bit, what is that, politically correct and say the spouse test, because sometimes it goes the other way.
Right?
Yes.
Yes.
But anyway, that actually ties into, remember when I said there was a caveat that I was going to throw back in, Scott? Wow, it's like you just fed me right there. The caveat is currently we are cyborg drivers. In other words, it is what's driving really well is a combination of human and full self-driving. So when weird things happen, we take over and then we can do it. But I think Scott's right too, because part of it is if you're just focused on the driving and nothing else, then there's a more of a tendency for you to intervene more rapidly. Where if you're not as focused on that, and I'm not saying in a bad way, like dangerously, but just if it's a little bit slower or if it takes its time to do something as if you were a passenger. So, so you just have to imagine you being a driver versus a passenger. Although some people are really bad backseat drivers, but if you're a passenger, you generally trust the person driving, and you don't worry about if they take a specific lane or if they make a particular maneuver in the way that you would, because it's not your responsibility. Whereas I think when you have the wheel of the car, and you haven't driven full self-driving yet, right? Unfortunately, in Europe. Yeah, I know. So
sadly not.
Yeah, but I mean, but you still have the basic version, right? That does the lane keeping and everything.
Not even that. I drive I drive a Suzuki, so I'm still not.
Okay.
I haven't even driven one, but I've seen enough videos. Right. But I want to buy a Model Y someday. I have a pre-order for the Cybertruck, but we all know that might not even come to Europe. So I have to wait for that. But that's something I really wanted to touch on. So that's my story.
Anyway, I guess so. However you want to put it, it comes down to the fact that when you're really focused on driving and you have your hands, right next to the steering wheel, there's a tendency for you to intervene more often. I think that's, sorry, I said it in a very long way. Whereas if you feel more like a passenger, if you're not paying as close of an attention, you really will let it go. And it ultimately does what it needs to do, except for navigation problems that still exist. Sometimes it just routes itself in very bizarre ways. But aside from that, it does a really, really good job. It is really, really close and much smoother. I'm sure Scott can attest to that too. It's like it used to be very jerky and now it's really smooth.
Oh yeah. Very smooth in a lot of things. There's you really have to think back at some of the issues they've had. I had a few other sort of challenging places right around me. I have this road that I call the Ents, because there are these trees that are literally in the middle of the road, it's just there. So they kind of paved around them. And at first it did not do a very good job of navigating through there because it was completely unmarked road, kind of narrow, but it's very clear there was a left side and a right side you should go. And it would just not know which side to go. And sometimes it would go around the left side rather than the right side. And then with this latest version, I went in there and just went right through, no problem. So I was able to see a lot of improvement there. And I think the other thing about distraction is anyone that's ever been in the car with me when I'm driving will notice I don't multitask very well. If I'm going to be having a conversation and driving, it's a bad mixture. So I'm almost like I am in kind of this background process of driving, and I miss exits and everything all the time if there's someone else in the car. But if I'm by myself, I'm all right. So I think that's the difference, that when I'm in there with FSD, I'm really focused on that. And then you have someone that I'll be having a conversation with, and then I'll relax a little bit and I'll actually let it do its job and not do the disengagement. So that's usually been the problem, is we can't tell how far FSD is really going to do something, because we will disengage because we're just not sure. But a lot of those,
or you're overcompensating or something like that.
You overcompensate, but you have someone like Whole Mars. He is so confident in it, he will let it do it. Whereas I'm the type of person that I'll just go ahead and disengage right away. I'm not quite sure what it's about to do. And part of it is the feedback. Is if they give us a little bit more feedback on the screen, like it would tell me like I'm about to commit, I'm about to accelerate. Because a lot of times it seems it's gonna go, and then it hesitates. And it's that moment of hesitation. Says, all right, I'm out of here, and then I take over. So if it would let me know that accelerating 3, 2, 1, 0. All right, then you would know. Okay, its intention is clearly the same that I would do. I will back off. So I really think they should do that if they want to get less disengagements. so we can really see how it's performing in some of those edge cases that I'm bailing out of. And John, I don't know how many you are bailing out of.
Yeah, I do. It's so difficult to remember. And part of it, I think part of it also is that we've been driving it for a while. So we're also trained on the earlier versions where you're like, oh, this is a bad spot, I'm going to have to take over. So it may be the fact that just because we knew that previously we'd have to take over there, we're ready to do it, and so we do it. But
yeah, we're literally on edge for that edge case.
Exactly. Yeah, we're on edge for the edge case. Oh, there's another good inside joke. Scott comes up with
another shirt on the
There's another T-shirt. Yeah. Jan, we'll let you have it this time.
Yeah. Thanks.
So, but here's an interesting thing. What Scott was talking about and us intervening, you can't do that with TeslaBot. So TeslaBot actually may help. I just actually, like literally as we started this thing, I released a video about who's going to get to artificial general intelligence first, ChatGPT versus Tesla full self-driving / Optimus. So I've been thinking about that, obviously, but I think that what we're going to see with Optimus is you can't take over Optimus as easily as turning a steering wheel or hitting the brakes. So it's going to have to become more autonomous, and it's going to be easier to tell if it really has gotten to a point where it's not making mistakes, because a human can't get in there and fix the problem right away.
Yeah.
So, and then they might be able to feed whatever kind of architectural changes that they've discovered back into to full self-driving at that point. So it's an interesting feedback loop that they've created with Optimus.
Yeah. Yeah. It's Scott, go on, please.
And for the record, the e-stop button for Optimus is back there.
Right.
Right. So if anyone happens to see one in the wild and is running amok, just go for that spot.
Slap the neck.
Someone distracted from the front, someone come from behind, and just right there. And that's it.
Yeah, I think that's a great transition to like maybe talk about the implications of FSD together with the Tesla bot, because I think what many people still don't really realize is Tesla is solving real life vision. So it's not about the car, it's not about the bot. It's like this type of technology is a game changer. They can put it in nearly anything they want. Right. I mean, it's crazy. It's such an interesting field. And together with Dojo now, which is a very strong supercomputer, really can emulate and simulate, and this is very exciting because they simulate road situations, and they also are simulating, of course, interactions of the Tesla bot. And when he's charging, he's still working on simulating what to do next and stuff like this. So maybe we can talk about these things, because about the brain, and then we can talk about the Tesla bot. I think that's a good transition.
I think you're right. I think the idea here and the uniqueness is that it's a generalized solution, and I'm not taking away anything from large language models. What's happening right now is almost miraculous in how fast everything's improving. But the data source is so much easier than the physical world. You scrape the internet, and the internet is a beautiful thing. It's like something that's been constructed over the last 30 years and contains most of human knowledge, or at least a great, great deal of it. And so it's just so easy to get the data, and training these neural networks is all about getting data. Whereas getting information about the physical world is incredibly painfully slow. It's really a tedious task. And so that's where Tesla has this massive advantage with having millions of cars on the road collecting this data. Whether or not the person's driving full self-driving beta, it's still collecting all the data they need. And then, currently they have at least 5 Optimuses or Optimi, but as they have 1,000, that'll be helpful. But as they get to 1 million and 2 million and 3 million of those, they will also be able to be collecting data as well. And that's going to be a huge advantage. Just how is anybody going to compete with that if you can't build that many of them?
Yeah, it's pretty tough. I think also when you compare it to Mercedes, who has their level 3 autonomy system already in place, and in Germany, huge news. We're here. Wow, yeah, the first European country solved it. Like in Germany, we have legislation now to have this, but it has strange quirks still. Right. For example, the air conditioning starts at full auto. It just goes off because maybe the windows are fogging. That's why it is mandatory that those go off, and this is by law. So something like this is super strange. And I think what I think is the entry barrier is a little bit higher now because I think Mercedes really lobbied with the lawmakers to enclose it a little bit, to have it a little bit in the pace of Mercedes, so the competition has to comply with those strange rules. And low standing sun, it has to disengage. Near tunnels, it has to disengage. Near construction sites, it has to disengage.
But and so on.
Yeah.
Isn't the maximum speed something like only 50 or 60 kilometers an hour? It's very slow.
Yeah, it's 60. It's 60 or 35 miles an hour, around that speed. And if the car in front drives faster than this, it disengages because it follows the car. So right now it's more of a traffic jam assistant, and but this will also change. I think they've already said that they're gonna increase the speed now to 80 kilometers an hour. So they're gonna raise it or around 100 kilometers an hour. And Mercedes also is. Like they really say like, okay, for 120 kilometers an hour, around like 90 miles per hour. I think it was.
I think that's 75.
Say 75. You're right. At 75, that's what they are capable of in testing and stuff like this. So, but
I hate to say this, and Scott, you can disagree with me if you want, but Tesla already does this. What they haven't done is they haven't taken away the steering wheel nag, but on the highway, I never have to disengage. Like it's just rock solid. And Tesla, what they're doing, instead of just turning off the steering wheel nag, I've noticed that they're slowly getting rid of it. So when the car is confident, it rarely bothers you anymore. And you're paying attention to the road. As soon as I look down or do something, it's like, you got to jiggle the steering wheel, but they're dialing it back. And I mean, not again, Mercedes engineers, it's pretty impressive that it can do that stuff, but Tesla tomorrow could turn on that feature. Like it's just like, that's already stuff it's done. It's a completely done deal. So they could turn off that. And now in the United States, not in Europe, obviously, because I haven't trained it there yet. But I'm just saying in this circumstance here, and you wouldn't have to have the lead car. You wouldn't have to worry about the sun conditions. You wouldn't have to worry about defogging because the camera's in its own little enclosed environment that has its own little defogger. So so all of that stuff. So again, it's really cool that Mercedes is doing that, but it's just kind of amusing to me that Tesla doesn't advertise the fact that they already can do this. It's in those circumstances.
I also think it's very interesting to see this, and also that Mercedes, Andrew Carpathy talked about this very thoroughly in this interview with Lex Friedman that he conducted, was that maintain those sensors that Mercedes is using. it's horrible. You have to, like, every hardware version. Maybe Scott can dive into this a little bit deeper because he's an aerospace engineer also. So, but still, that this is very, very interesting. What do you think about the approach of Mercedes? Because they just want to like secure everything and say, more sensors to be sure, but the failure rate is increasing. I think that's what Carpathy also said. But Scott, maybe you want to take over.
Absolutely. I mean, it's one thing to have redundancy, but the problem with redundancy is there more likelihood that some components can fail. So there's always that balancing act between making sure you have something that can back up a critical system, and the other thing of having so many of them that if one of them fails, then the whole system kind of goes down. Can you get by with just a couple of sensors? We do see that when using FSD, it will tell us if cameras are degraded and it's still able to proceed ahead, and it'll give you a little bit of a warning. And at some point, it'll just say disengage because the cameras may get fogged over, or it's really dark, or something with the sun is having an issue. But I don't see that. A lot of times you can completely over-engineer a system. And you over-engineer it to your detriment because now you're introducing more likelihood of failure everywhere around. And so we're seeing that always through the Tesla design philosophy is that the fewer components they can have, the better and better. And again, like aerospace, what they've done with the Raptor engines is that you want to 3D print it because otherwise you have to put things together. And that means you have to have gaskets usually between your plumbing. And the more gaskets you have, the more likelihood you have of a failure there. So get rid of them, get rid of them, get rid of them. And then, yeah, the performance is going to be better and the overall safety of your system will improve quite a bit.
Mm-hmm. And to touch on what Andre Karpathy said, oh gosh, was that AI Day 1? Whenever that was, he was specifically talking about not just the hardware aspect of it. Of course, the hardware can fail. Scott's got his earplug back.
Found it again.
He's back. He's
Perfect.
back. Would have been funny if you'd gone down and somebody else had popped up and been like,
yeah,
a Tesla bot.
Exactly.
Yeah.
Tesla bot shows up. But anyway, it's not just potential hardware failure points. It's also the fact that when you have multiple systems, so if you have ultrasonic sensors and cameras and radar and LiDAR, that's 4 inputs coming into your system. And one of them can say, ooh, there's something there, you better pay attention. And the other one says, no, it's not. And the other one says, I have no idea. And the other one says, is paying attention to the squirrels or something, you know, they could be conflicting with each other. And that is incredibly, I mean, Andre said that it was a fairly intractable problem. And it was only by getting rid of radar that and I know a lot of people really, really get on Tesla's case, but our new Model 3 doesn't have ultrasonic sensors and it doesn't have radar, and it drives great. Even in parking situations, it's not quite as accurate as the ultrasonic sensors yet, but it's almost as accurate. And so why have these things? Now, I think that the high definition radar is probably going to be introduced with the Cybertruck, or maybe it's already in the Model S and X with hardware 4. And that will give them, you know, in bad conditions like snow and rain and bad things like that and fog, it will give them an advantage in those cases. But for most cases, when the weather is reasonable, I think that it can do it all with 8 cameras. It's great.
Yeah, especially if I think it was a great decision to do this approach of minimalizing everything, because now you have the case, it's vision only. So it's just it doesn't rely on LiDAR. And now what we get, wow, the Tesla bot doesn't need to have LiDAR sensors now and stuff like this. And it's easier to adapt it to different projects they're going to use. So I think that's also a great example of their approach working, because now they can really adapt it easily. And especially also I can see in the future if legacy auto really doesn't catch up and can't figure out how to do this full self-driving stuff, they're gonna maybe license it to different car makers and put in our hardware and our just place the cameras in the positions we are placing them, and then you're full self-driving. I mean, this is an option that they could do along the way, but I'm not sure if they want to do it, but I assume that's part of their mission. They don't want to crush the competition. So I think
that unless there's if there's competition that also solves the autonomous driving, like maybe Mobileye or something, then I don't know that Tesla will necessarily do it. But if there isn't competition, Tesla's mission is very clear, and they're very much about safety. And I think that they would be willing to license it. You know, there's some complexity with that because every car is a different physical shape, takes up a certain amount of volume. And so you'd have to recalibrate the sensors. Actually, speaking of that, I got to look at the semi truck and walk inside it when I was there, the Tesla Semi, and where their cameras are very different than where the car cameras are. So I'm sure that they're working on collecting data, but that's going to have to be a completely retrained set to deal with the truck itself. But anyway, so I'm just saying, it's not as simple as just popping the cameras on and putting the hardware board in the car, because every car, and that's one advantage again that Tesla has. They've only got 4 models. They can update them, but the shape is the same. And so they only have to know the volumetric characteristics of 4 models right now, up until the Cybertruck, and then they'll have to have 5. So
I think it's astonishing what they achieved already, and I mean, it's crazy. And so Scott, maybe you can talk a little bit about the news that we got from the Tesla bot. We've seen an interesting video on the shareholder meeting. I'm going to pull this up right now so we can transition maybe to the Tesla bot now, and we can talk over the video. I think you can tell us what
the first thing
see.
is notice that it walks a lot better. It's definitely more erect, straighter up than it was in the past. This here, we're going to definitely talk about this, the motor torque control and the ability to literally stop instantaneously when something does not seem to be right based on what your expectations are. And of course, you can also go outdoors. And from here, the mapping. I know John wants to talk a little bit about the mapping that's here and the nerfs that are being used to create that.
Right.
And then here, we did quite a breakdown on that. And we'll talk a little bit about what that headset is and what that means, and also the teaching, the end-to-end, and also why this engineer is so gleeful at what seems to be a really mundane task right there. That is also a very flexible object that it's learning to pick up.
Right.
You see, it was trained by what we are calling the sensei. This is no longer a robot programmer, but someone who is demonstrating. And of course, here we have is kind of the line dance of 5 Tesla bots in front of 3 Cybertrucks. So we know that there's at least a minimum of 5 Tesla bots out there. I suspect there's more than that. I think it's probably more in the order of a dozen, something like that. So pretty close. So they're showing about half the fleet at that point.
Yeah,
and of course, some of those might be taken apart on work tables and stuff. So
yes. Some of them were being demonstrated there. So I think the first thing to kind of transition in is that the Tesla is basically solving 2 problems at the same time. So you've got the humanoid and also the ability to navigate a car in the world. And there are some slight differences. I've mentioned this to John. The difference between what you have to do with full self-driving is the car only has to navigate in the world, whereas the Tesla pod has to navigate and interact in the world. But they are not mutually exclusive problems. There's a lot of similarities there. And so Tesla bot has learned from FSD. And the question is, can FSD learn from Tesla bot? And it's like, yes, it will. And this is kind of the theory that I've had, and that we'll talk a little bit more right now with John, is that the FSD is notoriously not very good in parking lots right now. Right. And parking lots are very different than being out in wide open streets because they are very dynamic. You're really not sure where the road's going to be, and suddenly a car coming out in this direction, and you have to drive a lot slower, and your precision has to be a lot better. So when they're driving out there, the occupancy network can have much larger volumes of what is an occupied area. But when you get into a parking lot, it's different. And we know they've had to scale that occupancy network down for Optimus to be able to go around. So it only makes sense that, once they get Optimus to be able to work in these more enclosed environments, it's probably going to go back at FSD and help FSD understand how to navigate parking lots a lot better, more of these low speed applications, higher precision. So that's sort of my theory, that the 2 are going to be there. And I don't know if this backs anything up, because John put one of his first videos out there exclusively on Twitter, and it got a like from Elon. And I don't know, maybe the like was the fact that it was exclusively on Twitter, not necessarily the content. But if the like was the fact that we were thinking that they were going to feed, because in the title there was something about the feedback loop between how Optimus is going to also inform FSD. So take that with a grain of salt. It might be that we actually were onto something there. And if you want, we can now go into breakdown of each scene.
This would be a great part for the thumbnail. Very clickbaity. Elon Musk confirmed.
Confirms.
Confirms.
That's all we have to do. That sounds like the standard way to get a whole bunch of clicks on your video.
Yeah, of course.
Right. Exactly.
Elon Musk confirmed Tesla bot is flying now.
Right.
Yeah.
You heard it here first. Exclusive.
Exclusive. Yeah, but that's pretty interesting. You meant with the fidelity, these blocks, because they just place everything. Yeah, they're gonna and they already talked about this last time on, I think it was on which day was it? Was it Investor Day or on the? I'm not sure. They talked about scaling down the blocks already.
Yes, I think that might have been the AI Day too.
Yeah.
Yes, exactly. Of course.
Yeah, they're first showing it. Yep.
Right. And I was, since I don't know, Scott, if you were there with me, but after, I think it's okay to say who it was. I kept saying an engineer, but it was actually Ashok that Elaswamy, who's sort of the lead, who did the occupancy network as just a weekend project on his own, which is just kind of mind blowing. He's like, yeah, I'll just code this thing up. Yeah, I know, right? But he did that, and I talked to him after the presentation, and I said, you know, how big are the blocks? They're approximately, like, I think at the time they were around 30 centimeter cubes on the side. And so that's pretty big when you're dealing with an Optimus bot, right? It has to be much smaller than that for it to be able to manipulate like a cup or something. So he said, oh yeah, we've got basically an infinitely variable voxel size now, so that the cubes change from very small close up to very big far away. And that just opens up the door. And clearly they're doing that now. And clearly Optimus is doing that. Although it can probably keep it a relatively small voxels because it moves slowly, but the cars are obviously doing that, where if it's moving slowly and you're up close and you're parking, it's using very small voxel sizes. And as you are driving faster and you see things further away, it uses bigger and bigger ones. So that, because the problem is it's an intractable computational problem. If you have to have little tiny voxels like this big out, you know, a kilometer away because you're driving on a flat road, it can't do that. There's so many of these voxels that it would never be able to do it. So it has to extend them. It's, if you think about video games, if for people who happen to know anything about video games, it's level of detail backwards. So what you do in a video game is the far away things are on, they're very, very broad. They're not very detailed. So you might have a model of a tree and far away, the model of the tree is actually just honestly, it's a 2D image of a tree on something that's just pasted to a flat plane. But as you get closer, you get trees that are higher and higher and higher detail, until right up next to you, as you're walking through the tree, you see the leaves and the branches and very, very high detail. So it's that, but it's doing it backwards because it's taking in the information of the world and chunking it up in that way, not actually creating the world. So super, super cool stuff. It's just, I love it. And I love the fact that now when I drive by on the road, just a pile of junk on the side of the road, like an old tire or some garbage that fell off of a truck, the car, you'll see it. It actually turns into a little gray blob as you drive by. And so it doesn't know what it is, but it knows something is there. It says
something
like,
to be avoided.
There, don't hit that. Yeah.
Yeah. And I think as far as the parking lots go, it's not quite that bad, because I had a rather interesting situation about 3 or 4 weeks ago. I was heading to a destination, and it was sort of a new way that the navigator decided, oh, we need to do this because there's some construction, a few other roads. So it was kind of a detour I was going in, and it decided to get over into the left turn lane for the upcoming left turn. The problem is, it was one of these left turn lanes that was actually kind of short, and there was another left turn lane just before it to go into a strip mall. So it made the mistake that I would have made, because I wasn't even familiar with the area. And it kind of said, oh, there's a left turn up here, let's go over. And it gets in, and suddenly it's like, oops, I'm in the wrong left turn lane. But it acted so confident, unlike what it was doing, that I didn't disengage. Like, oh, it must have found some like tricky way around here. This is going to be interesting. So it goes in there and suddenly, whoop, I'm in the parking lot. What am I going to do? So I just said, all right, let's just sit here and wait, you know? And it got itself through. It figured out how to get out of the parking lot over to the road that it was supposed to go into. So basically kind of took a shortcut on a left turn lane, on a left turn to get on over there. So it can do it if you're patient enough. The problem is sometimes we run out of patience, and we're a little bit nervous because suddenly a car is backing out or something else. But there were cars there, but there wasn't a whole lot of activity in the parking lot. So I felt I could let it do it. And and there was no map data for that. It just had to figure out where that exit was to get itself through there, and it did it. And so that's also what Optimus is going to have to be able to do, is to navigate an environment. It has no mapping data for it at all to even have the first guess of what to do.
I will add to that one that so when I went to Investor Day, I obviously flew home, and I got in our car, and actually my son, weirdly enough, was flying in at the same time, so I was driving home with him. But there was a huge detour at the airport because, as always, they're doing construction, and so instead of going right, you went left onto what wasn't really a road. It used to be a parking lot, and it just had barrels, and it kind of, so the car saw the detour, saw the fact that it couldn't go right because it was navigating to the right, went left, remapped it on nothing. It had no idea what the road was. You could see on the map that it didn't even know where it was. Like, it didn't know what road it was on. It knew where it was, and it figured out how to do it. And I was like, whoa, it was amazing, because that's nothing that it knew about. It just went, and it was like, well, here's the barrels. I got to go this way. And eventually it gets back to a main road, and it took a left and kept that. It was like, wow, it was astounding. It was very, very cool.
Yeah, what interesting is, I'd like to add something there, that Google Maps, for example, also is like this, that it can, like when you drive past an obstacle all the time, and many cars pass through and avoid an obstacle, and together with the satellite imagery, I think they map the roads by AI like
Right.
how the road is going, and then they realize, oh yeah, okay, there's this construction site, and the map changes then. And I think Tesla could implement something like that also, for example, in those cases where's the road, and then Tesla maps this road for all the other Tesla users. Then
for sure that should happen. There's a place that had construction. They built a new Costco where I live, and they changed the road, and they moved the stoplight about maybe a couple of 100 meters away from where it used to be. But Google Maps still doesn't have that updated. I have no idea why. But the car has to drive it, and it actually does fine, but then it doesn't realize there's now a hole in the road where you can go across. So it routes this crazy thing where it has to do. So I have to take over then and turn left, because it would be stupid otherwise. But it does an amazing job when it doesn't have navigation data. It's very impressive how well it drives. And I don't know, Scott, if you've had, I mean, I guess the Forest of the Ents, where it kind of is like these trees in the middle. It's just like it's just a paved area with trees in it, almost like a parking lot.
Yeah. And you're going through and having to go around these obstacles that they don't even have reflectors or anything else around there, or curb or any sort of indicator, just trees growing up in the middle of the road. Which is a unique obstacle, I would say, that you're not going to see anywhere else. And it's not like there's just one or two. I think there's at least 6 or more as you go along there. So that defines the middle of the road, but there's no yellow line or anything like that. And at first it had difficulty with it, and now it's gone a lot better. A couple of my other turns that it got wrong, it's definitely doing now. So there was like this right turn only lane that it just didn't figure out that it should not be in that lane, that all the locals know you get out of that lane because it's going to suddenly force you off over here. You need to get in the left lane to go straight. And I don't know if it was mapping data or something else. It kept on thinking it had to stay to the right, even though I'd coax it to the left, like, come on over. And I'd get in there and say, all right, we're all established in the left lane. It's going to know. And it's like, nope, going back on over. It's like, no, don't go there. And we just kind of almost had this argument back and forth and who was right. And now when I've gone down there, it understands it a lot better. So it's getting over there. So I am definitely seeing improvements and things like that. And traffic circles are much better as well.
Yeah. I think if this gets solved in the next with all those data, with the data sets they are training, I think it's going to improve steadily. But maybe a question to you both. How do you think when is the point where where we can really expect FSD to be really working? Maybe also with the improvements of Tesla Bot, with the smaller or slower speeds and the voxel size in the parking lots and the parking lot situation. So with everything all in one, what do you think? When can we expect this to happen?
I'm actually starting to see a strategy on Tesla's part that I think is kind of brilliant. And that is, I think that it's I don't know, like if you, this is a terrible analogy. Gosh, what am I thinking about? It's kind of weaning yourself off of something. I'm trying not to say like a bad habit or something, but if you have a bad habit, instead of trying to just not do it at all immediately, you start to like back off on the amount of like times you do it or something. So I think what I'm seeing Tesla doing is that they're reducing the amount of times that the car nags you, is as long as you're paying attention. And I think with their strategy, instead of just one day going like, oh, we've achieved level 3 autonomy all at once, what they're going to do is they're just going to keep lowering that bar until in many circumstances, as long as you're looking at the road, it's okay. And then they can say, you don't have to look at the road anymore in these circumstances. So I think what they're going to do is just kind of keep lowering it and lowering it. And we won't even notice. And by the time it actually gets to level 3, it will have been that way already for a long time.
Okay.
My feeling is that what was sort of preventing them from getting to that level of autonomy was the heuristics that were in there that were creating what Elon refers to as those local maxima, and they just could not get everything to go. And once they get the full end-to-end, and we're starting to see that with FSD coming into the highway part of the stack. Once they have that full thing, then I think the S-curve is just going to be dramatic. And then Elon kind of, he talked about there's going to be a ChatGPT moment, which is maybe his way of saying by end of the year without saying by end of the year anymore, because he always gets nailed on that. And it could be that they are seeing something that when they've gone that way, the improvement is happening really quickly to the point that they themselves may even be surprised on how rapidly it starts to converge, just as everyone else at OpenAI was when suddenly, ChatGPT 3 and 4 come out. And then there seems to be a lot of emergent behavior there, and that is very good. However, it is cautionary because as clever and as persuasive as GPT is making us think it is human and conscious, we know it is the biggest bloviator out there and fabulous as far as like making up data and facts and everything else. So I don't want the FSD to be, fantasizing that, oh, wouldn't it be nice if this road was over here? And just imagine, let's just take this road, It'd be nice if there was a
Let's
bridge.
imagine a road over here.
Yeah.
So, yeah.
Hey, that's why we need the Cybertruck. In case it drives us into a lake, it'll just keep on going.
Yeah, that's true.
I have to say, the other day, yesterday, in fact, I was looking for some airplane tickets. And I said, why not ask Bard, because it has access to the internet. And so I asked it to get me some airplane tickets and give me the flight numbers and the cost of them and everything. And it came back with a list of like 10 flights. And I was like, this is great. So I went and checked online. Not a single one of those flights was a real flight. No prices were real. Yeah, it was all just completely made up. So it looked good. It was like Delta Flight 2701, and I was like, oh,
the flight
that's
I
great.
want. Yep.
Yeah, but
from this airport to the airport, super bargain.
I
it leaves at exactly the time I wanted to leave.
$220, and I said, no, that's not a reasonable airplane flight cost anymore.
Interesting. Yeah, pretty interesting. And then it imagines the airport. Wait a second, there is no airport.
There is no airport there.
Yeah, crazy. Oh, okay. Yeah, but how do you think that Twitter plays into this whole thing? Because this is also an interesting theory that, of course, Elon Musk has something in mind with X.com and with this like putting everything together. And now they have a huge data set of interactions between humans communicating, more or less discussing stuff or being a little bit rude to each other, but that's how Twitter was and always will be, a huge platform for discussion. But how do you think this plays also into this whole idea of taking everything together?
I think what's going to happen, and probably sooner than we think, I don't know, maybe they don't have time to work on this, but I'm imagining a very in-depth conversation with your car about the nature of the universe or something while you're driving, because they'll just stick a large language model on top of it and it'll just be able to respond to you. That's a little bit, glib, because I know they have to use their processing power for the full self-driving, but I think it's a no-brainer that they would either create, like Twitter would create their own, or X Corporation, XAI, will create their own large language model trained from the ground up, or they'll take something like Llama that Meta has released publicly, and they'll utilize that on top of it. And so a voice interface, a natural language interface with your car, and then especially eventually with the robot, is going to be demanded. Yeah. You're not going to want to have to type commands to the robot or do the things that you do with, I'm not going to say the word ALEXA because otherwise it'll respond to me. But anyway, you say that and then you say a command and it responds back. That's really simple. Humans are going to want to be able to have a conversation and a history with especially Tesla bot, where it's like, oh, do you remember yesterday when we were talking about this? And it can remember that and it can continue a thread of conversation. So I think it's a complete no-brainer that large language models are going to get stuck on top of this stuff.
I mean, also if you think of Siri, for example, which is in Germany, especially in the German language, it's horrible. You can even really, it's non-usable really. Alexa is much better. Oh, sorry.
It's okay.
But it didn't trigger it, I hope. Oh, shoot.
I told you can't say it.
Yeah, sorry. Yeah, I know. It was a mistake. But I think this is interesting when those language models are implemented, and I can imagine that you sit in your Tesla, just even normal directions, or say, start the climate controls, make the car hotter or less hot. I mean, this works already in some cases, but I think it's gonna improve when they introduce something like this, and I think this isn't far-fetched.
This is a good question on that, because I'm thinking that you would have more voice interaction. The thing is, right now it's painfully slow. So you got to push a button, and then you say, open glove box, and you sit there and you see some text come out. Oh, you just hit open glove box, and then boom, it comes out. So there's always that suspense of, did it get it right? And I think it might be that the slow part is probably the voice to text.
Yes.
And I don't know whether they can speed that up, because I assume if you had typed that text in immediately, the large language model could react really quickly and say, oh, I know what you want to do, and make the glove box open.
Right.
What do you think? What could they do to speed that up?
I believe that is being run in the cloud right now. I think that's the big thing. Just like ALEXA.
Voice recognition, yes.
There's a huge delay because it has to go to the cloud, has to do its thing, and then has to come back again. And that's multiple seconds. I was actually just talking to Lance King and the Cyberlander, and he said that one of their goals is to be able to do everything. They want, large language model interaction locally on their processor, so that none of the stuff has to go to the cloud. And I think that's because you can see that when there's a no connection error. Because I'll say, like, navigate to this pizza place or something, and it's like no connection, and you're like, oh, come on, just interpret what I just said. So it should be able to do that much faster when it doesn't have to go to the cloud.
Especially for things that do not require any outside information. If you're asking for a pizza joint, there's two things going on. First, it's going to convert the voice to text, so that's using a cloud service. And that's like, oh, you're looking for this pizza joint. Where is it? It's not in my directory. I've got to go out to the cloud and find it. So it's something like open the glove box. Well, that's local. Open the window, close the window, heat up, heat down. So I think the voice control is really nice. The only thing is it kind of lags a little bit. So if I was to ask a passenger to go ahead and do that for me, they would do it a lot quicker than the voice command right now. And it has to be as fast, if not quicker. Yes. So to get to that state of why you don't need buttons in the car is like, you should not need buttons. You should just be able to say defrost, or you don't even have to think of defrost. You could just say, my windows are foggy, and then it will know, oh, I should turn the defroster on. And that's one thing that's kind of nice, is that you don't have to know the precise command. You can give it kind of a hint of what it is you want to do, and it will figure that out. That's a huge improvement over old command lines where you had to type exactly in, on DOS, it was like you had to type in dir to get a listing of all your things. And if you just said, arbitrarily, oh, show me all the files over in this folder, it would know, oh, you mean the dir command, right? And then go ahead and run that.
So I think that, currently what's in the Tesla is the same as what we're getting with Siri and all these other things, where you're just getting, you're getting a very straightforward command response thing, and there's a few canned responses. That's what you've got. But I think what Scott says is exactly. So you might not have a deep philosophical conversation with your car, but at the very least, you could say, you drive into a new town that you've never been to, and you're like, man, I'm really hungry. And then it responds and says, well, what are you interested in eating? What, you're like, I don't know, maybe Mexican food, maybe, some bratwurst. I don't know, and so you give it some options, and then it thinks about it for a while, and it comes back and it says, well, here's what I found around here. And then, so it's that iterative nature. So rather than a single command, single response, it can iterate something, so you can have a conversation with it to get what you really want in that situation. And I think that's going to be, and especially with the Tesla bot, that's going to be very important. Because at home, you might say, oh, Tesla bot, my house is dirty. And so it might say, like, well, what do you want me to clean first? Or, what's a, so it can think about that in a more conscious way, like a human being would.
Yeah, Scott, please go on. I didn't want
I was just thinking, riffing on what John has talked about, you're going into a town you haven't been to. It's one thing to find the restaurant. The other thing is to find the parking and where that's going to be.
Oh, gosh,
so a lot of times you're navigating around, and then when you do find the parking, you get out and you look at it, and it's like some strange app you've never seen before. Like, oh, I've got to download this app and do everything else. And that's why I like the idea of, if Twitter is like the only app, I want to be able to just pull in this parking space and walk away from my car. That's it. I just pull in wherever I am.
I'll one up you,
where
Scott.
you are. Yeah. It's like,
what
are you legally parked?
I should just circle the block until you're done, and just because it's.
Well, that's the other thing. But if you wanted to park, it should just go, and it should just say, it pulls into a parking space, and you walk away, and it just negotiates with whatever
Right.
Local
No, I'm saying
there
even better though.
comes
It
to
just
parking,
drops you off at
figure it
the
out.
restaurant and it finds a parking place. You don't even have to
that's
think
the
about
other
it.
thing. But for now, I would like it, because there's still going to be us old school people that are just like, oh, we got to park the car, get out and walk on over there. But you're right. Eventually it's going to be, it drops you off. But you could see apps like that are kind of putting everything together. And if it knows more, like, again, it's not just paying for the parking. I think somewhere it must be information about which parking spaces are actually free. So you don't have to have a drone fly over, anything like that. There should be some central database that kind of knows it's there, but I don't know if anyone's been able to tap into it to say, oh, go over to that street right now. There's 3 parking spaces available.
Or even better, the car just drives around, tries to find a parking lot, then it realizes, oh, it's pretty difficult to do. Oh, I got a taxi fare right here. I could pick this person up and drive him there. And then he says, oh, true. I've earned you some money while you ate, by the way, and I've recharged already. So
that'd be cool.
That'd be really cool.
Now the key is for the recharging is that right now everyone's just thinking that you want to pull up the charger and that somehow it automatically goes ahead and connects to the Tesla. And those kind of ideas have been around, but they're very, very complicated and they cost a lot of money. And it would be a lot cheaper just to have a Tesla bot sitting there tending the whole thing.
Okay.
So if someone comes up, it just goes out and plugs in, just like a gas station attendant. So if the Tesla bot costs, like, say, $10,000, which is what we're suspecting will be the actual cost for them to manufacture it, that doesn't cost anything. Whereas if you had like this weird snake robot thing that goes around, does everything else, that's also going to be about 10 grand. And then you're going to multiply it by 16 stalls. And now you've made the complexity of that. And if one of them fails, and then the best thing is to get rid of all the complexity in those things so that your superchargers are reliable. And all you need is someone to come over and do it. Plus, it'll pick up the trash that everyone keeps leaving around. And maybe they'll actually have a squeegee over there, and Tesla bot will come up and like clean your window and then ask for some money afterwards.
It'll be just like the old days when you go to the gas station and the guy would pump your gas and clean your window.
Yeah, exactly. This is going to be like when you stop at a red light and the squeegee man comes up, right? So that'll be the Tesla bot.
Yeah.
That'll be the day when the Tesla bot asks you for a tip.
Yeah. Then we know we've reached AGI.
Exactly.
Yeah, but maybe we can watch the video again, and maybe Scott and also you, John, you can comment. I know it's a little bit fast. I can't stop the video, sadly, but we can just brush over it and repeat the video and stuff like this. Maybe look at this.
Okay, stuff. So if you pause for a second, the main thing again is that notice it doesn't seem like it's squatting down, and that motor torque control. So first of all, it's a lot better. It's not down like this walking uncomfortably. It's starting to get more erect. So we're seeing the improvements there. A lot of it is coming from the control down in the waist or the pelvic area to be able to get that nice motion to keep your torso nice and straight. So we see improvements there on the walking already.
It is, however, still flat-footed. It's
still flat-footed. They've made some upgrades to let's say the foot pads are on there, but basically it's the same idea, a flat foot without any arches or any other.
But I mean, in terms of the mechanics of it, it's stepping like this.
It's still plodding down. We don't see any flexibility in the foot. It's just coming on down. There's no heel toe strike or anything like that.
Yeah.
You don't really see a toe off yet. It's getting like really close to you, sometimes almost see it, but really the foot is coming up and going straight down, up and down, up and down.
Yeah, right there.
Yep. Then you have the motor torque control. And this is really interesting because, that is just a disembodied leg that they're doing that test on, just sort of show how rapidly they're able to respond to something in the environment that was unexpected. So robots will typically move around and they know exactly what the motion is like and what the forces and torques that are expected as they move around. But if suddenly they encounter something that was not there before when they were taught, they need to stop instantaneously because it might have been like a human operator or some obstacle suddenly got in the way. And being able to come to a dead stop on that is really, really hard. Right. You need a lot of torque to be able to do it. And you need to also be able to sense it very rapidly. And so that is quite impressive.
If it's maybe for people because it goes by really fast, but what's happening is the little rubber stopper at the bottom of the foot is hitting the ground. So that's its intended target. And you've got an uncooked egg that the guy puts in place of it. And it immediately is able to stop.
Yes. So when you do this, you'll see it's going down. And now, okay, I'm just going to put that in there. And it's going to say, oh, wait a minute. That's where the floor is. Now, it doesn't mean that this is great for not breaking eggs. It also means it's great for that when the foot comes down on the floor, they can't quite see exactly where it is. And do you want to come down like that every time?
Right.
Yeah.
You hear his clop, 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 or it's kind of going on down there, and then it's able to sense it and make kind of a very smooth landing every time. So it'll be a little bit softer. And that's good overall, because if you're coming down, let's say you're walking on uneven ground, something it's a little bit higher than you expect, and you're coming down a lot faster, you get that, and suddenly it's going to cause you to tip or be a little bit surprised because you're putting a lot of force. So that's also good that they can react that fast. And I saw it as like that had absolutely nothing to do with the foot, even though it really does. I think it has more to do with the hands, because if they get that level of sort of feedback control on the sensors, that means they can actually go in and apply the same thing to the hands. And when you do the gripping of a hand, you really have an idea of what it is that you're gripping. And as you apply a little bit of force, the kind of the feedback you get from that, you can tell, is this a very hard object or is it a very soft object that I need to maybe close down a little bit more? So that's what I saw immediately. Say, oh, the hands are going to get a lot better. It has really not everything to do with the feet. And it shows that the response rate and the torque that they have in those motors is impressive, to be able to come to a dead stop that quickly.
Yeah. And what also is very interesting, what is up next in the video is the mapping. I think is also very important, because let 10 Tesla bots walk the same path, and suddenly your whole environment is mapped very detailed. And I think this gets better and better the more times the bot walks past, and they can really also map environment changes and stuff like this. So the bot already knows what to expect, but if something is changing, they're gonna adapt it to the neural network. And maybe you can comment on the next phase of the video.
I think it's the next part.
Yeah, John did a whole video on the next phase.
I just did. Yeah. Can you get a big shout out? Scott would have joined me if it hadn't been for his giving tours at KSC. So, but yeah, it's that last part where it has the point cloud, where it's basically remembered. It's created a map on its own without needing Google Maps or anything else. It's doing it by, and I think nobody knows whether that was one single bot just walking around and around and around, or whether they had 5 or 10 of them that were walking around learning it together. It doesn't really matter. What matters is that it's figured out the environment, and it knows where it is on its own without needing to have a separate mapping entity, which is super, super cool.
I can't even put it into words. If you see when it's mapped and everything seems to come together, and especially now with the training setup they have. Maybe Scott, you can comment on this again afterwards.
Yes, so we'll be coming up to that point. I don't know if you'll be able to freeze the frame when we get there. The other thing we should point out is that there are Easter eggs in here, not just that egg, but there are a few places where there are some eggs that show up, and one of it literally is an Easter egg that has got some coloring on it. That when we come up and we're able to just a little bit, if you want to pause there, that could be, right there, pause. So what we want to see is that you'll see there is a human that is demonstrating everything, and we don't want to call that a robot programmer anymore. That person is a sensei, because they're doing everything through demonstration. They're showing how to do something, and now the student, in this case Optimus, has to be able to repeat that task or begin to learn that and understand it. So there's going to, the programming is going to be physical demonstration. It's not going to be coding. It's not going to be writing lines of code and debugging or taking a robot teach pen and going through and testing the movements again and again and again. So this is quite the step change, and in the means of being able to program a machine of this kind of complexity. And again, it's one of those things I think eventually is going to make it back to the industrial robots. So industrial robots are not going to be replaced by Optimus. They're going to be improved by this technology. So a lot of the specialty robots are really good at what they're doing, and they will continue to do that. And there's no way a general purpose robot will replace it, except on the fringes. So I think, ironically, there may be some cases where some industrial robots are replaced by Optimus, but the majority not. So your spot welding robots, they're not going to be replaced at all. Some of these robots that are doing really heavy pick and place or palletizing, depalletizing, where speed is very, very important, those will still remain. But the way we teach them today is laborious and tedious. And so this kind of approach will be a lot better in the future, to know that half the cost of getting an industrial robot in is not the hardware, but is also the guy you got to hire to go in and program the robots and everything, to coordinate and everything together. So if that can be eliminated. Now, we were trying to figure out what this headset was. And there was like an Easter egg off on the left side somewhere. And a Twitter user, Ronig, he kind of pointed out, because John and I were like, why that heavy backpack? You can't quite see it, but there's a really big backpack that he is wearing. And it's like, well, the backpack is probably the torso of Optimus. So it is the FSD computer, it is everything there. And we were looking at that and saying, oh, look, they got these cameras that are probably emulating the cameras that are in the head. And there's 6 of them there. We can see 2 on the side, 2 looking down, 2 looking straight ahead. Then we realized that, wait a minute, those are the cameras that are inside the head. So that's what's actually happening there, is that if you want to have an idea of what the cameras are, the camera placement is, you can see it right there in that picture, and it's right on the helmet. Yeah. And now the thing that's a bit of a challenge here is that human kinematics and the kinematics of Optimus are not quite 1-to-1. So Optimus cannot move its head at all. It's there. And the sensei has to be very careful not to use his head very much. Head motion. He does it in a few cases that you'll see his head's kind of turned over this way, but Optimus's head is not. Optimus's head is somewhere else. So which means the field of view is a little bit different. And they have to probably do some mathematical tricks to be able to compensate for the fact that the human is not exactly the same, not only kinematically, but the lengths of the arms and everything else. So there's some challenges, but
I would also add in there that the human has to look down several times to see the objects, but Optimus has those downward looking cameras. So you can tell that in the virtual simulation, it doesn't look down because it can't. It doesn't have a neck.
Exactly. Optimus will be looking down at things like this, with only being able to do this with the torso, where the human, it's like, my work's down here. I have to look at it. The only way to do it is to give them those little mirrors that your dentist has or something like that. That's like, okay, I can look straight ahead, but I'd be able to look down.
Right.
That might be a future solution they do.
I also think, of course, that this is just an iteration. I think this will be maybe perfected, and I think I mean they can develop it if they run into those problems as well with the head movements. If it's too complicated, I think they can. Maybe there's a rig that is like bigger, and you can move your head, but the interface stays still, or something like that, like an exoskeleton.
They have it like on your head, exactly. So you're going around like this, but it's that's another possibility.
It'll be an Optimus space helmet at that point.
Exactly. Yeah, that's true. Yeah,
that's a potential solution. Now I know a little bit later in the video there was kind of that moment of exaltation where you saw that one engineer throws his hands up like
he was
sort of touchdown.
Very happy to see what was happening.
Exactly know what that was about. And then there was a tweet from a Tesla bot engineer who said that today was the first end-to-end grasp by Optimus, and you can see it in the video. And so it was probably when the bot went over and picked up what is either a potato or a lemon, I can't quite tell, but it did that very first grasp. And that was the very first end-to-end, meaning they were able to demonstrate grasping, and it went ahead and did it. They did not have to code that. So right there, end-to-end manipulation, images to joint angles. And that's, of course, exactly what I think version 12 of full self-driving is supposed to be as well. Everything will be pretty much end-to-end without any heuristic code in the middle. So it'll see it, it'll know what to do, it'll grab it. And at first when we read that tweet, it was like, well, wait a minute, we've seen it being grasping things in the past. I mean, back to last summer, they were already picking things up and dropping it off. And that was more or less a mechanical proof of concept that we know it can do it, with a lot of hard coding going on in there to getting it in there. And there was probably some sensor feedback to make sure it was able to guide itself to the particular part the way you wanted. But every task was still very manually hard coded. And now they've been able to sort of throw that out and bring in a very new foundation, which is we're going to demonstrate the techniques that are going on. We're going to demonstrate the task. The robot is going to learn from that, and then it's going to execute that, and we're not going to have to code anything. Right. And when that happens, you're talking an S curve. Right. So it might be the next month things are slow, but then right after that, things take off.
Right. I think the probably, so what we're going from is a computer program that tells it each step of the thing to, I don't know exactly what it would be, but in a natural language sense, something along the lines of pick up that object on the table. So that becomes the command, which is much more of a human understandable command. So something that a non-programmer would be able to do. You say, pick up that thing and bring it to me. In order to do that, it requires so much. You don't think about it because humans do it without thinking about it, but it's really complicated. You have to figure out where the table is, what the object is, how big it is, how hard do I have to grab it? You know, there's a lot of steps involved and a lot of complexity. So it's incredibly complicated not to hard code every single piece of it and have it pick it up. So,
and I would think they're going to have to tie it into a large language model at the same time.
Yes,
that's what I wanted to get into.
So it's not going to be that, you know, I just kind of turn to Optimus and like a, you know, wink and, you know, look at me over here and just grab this and do it and have it do it. I should be telling it what I'm doing. Say, hey, Optimus, look at me. With my right hand, I'm going to pick up the water bottle right now. I'm going to place it over here. And then, you know, can you do the same thing? And then, you know, Optimus will try to do it. Say, yes, I can. Say, well, what about if I pick up the water bottle? So you want to associate those tasks with the language. So the next time I say, okay, grab the water bottle, it knows to grab the water bottle and not the mic and maybe not the Coca-Cola. So you're going to have things that are very similar, but it's going to have to understand the nuances and the differences that are in there and what you mean. So eventually you don't have to demonstrate anymore. You're going to take it back and just tell it, oh, I would like you to do this right now. And it's able to say, well, I associate all these tasks with these words. I know precisely what you mean. And of course, hopefully it will talk back to you like Alexa, or others do to make sure that it understood the command right. So you will get that. It's like, go get me a beer. And it'll say, okay, you want me to get you a beer? And then maybe it says, well, okay, I know you prefer light. So is it going to do that? Or maybe it's going to query. So, well, which one do you want? Do you want the IPA or do you want the light beer?
Right. And what I also find very interesting in that sense is that combine that now with the capabilities of those language models also to do coding. So that means if it doesn't understand something or it learns something new, it codes how to do it. Maybe, like, I don't know. I'm not into coding as much. So it's a little bit naive maybe to think about this, but this could be like code fragments that are not that it didn't learn. It just codes to the task maybe. I'm not sure.
In a sense, whether it be throwing together a script or not, I'm not sure. I mean, it's very clear that you can ask it to do certain things, and this is something that we're trying to experiment a little bit, John and I. That we have a lot of scripts that tell our simulator what to do, and we're trying to figure out how easy it is to take a large language model to write that for us. But I'm wondering whether Optimus and others are ever going to have like some sort of script or something like that they run, as opposed to it's just done by the net itself. I mean, that could be one way, but it might be a bit of a crutch at first to say, okay, we were coding like this heuristically in the past. So we had to have a man in the loop, a human in the loop sitting there writing all the code to get Optimus to do a series of actions based on some subroutines and everything else that we had already sort of built. And now you're saying what you could do is say, do this task, and Optimus, like, it understands the API so well, it writes the script it needs to make itself go ahead and do something. That's one possible solution, but I'm not sure that is it's one of those that will get really short-term results, but long-term, I think, again, you hit a local maxima. It's going to be more innate, instinctive, that it just knows what you want to do. The other thing I want to point out is with them going kind of end to end, and why things are going to get a lot better is that when you do things heuristically, the human body is so complex, you have to break it down into sub-problems. And so you have like a solution for the left arm, the right arm, for the torso, for the legs. And then you try to figure out, how do I coordinate the two together? But the solutions are kind of done separately and then melded back together. And maybe there's a little bit of tweaking you try to do to get one to kind of work a little bit better together, but they don't see everything holistically. It literally is like the sum of the parts. And what you need to be getting is that, you know, it's the whole. It's not the sum of the parts, it's the whole. And right now, the neural network is seeing the whole kinematic structure as a whole. It's not seeing it as a left and a right arm. It's like it wants to do something, and when it does it, it has to twist the torso, maybe lean in a little bit to get that shoulder in to go ahead and do something. And meanwhile, if I get my other arm that's supposed to be holding on to something, I want to keep that in space, I have to coordinate the fact that as this shoulder goes forward, this other one has to compensate. That takes a lot of coordination. Heuristically is really hard to do. But if a neural network just figures that out, because we have very natural fluid motion. Through our just years of training and testing it out. And now that's what you're going to see, is that the neural network is going to figure out that fluidity naturally without us having to go and hard code things and change a perimeter here and a gain there and something else.
Yeah. So I think your original question was, is it going to be able to code things? I mean, yeah, because if it has a large language model attached, but it won't need to, because that's not really the paradigm.
Yeah, maybe I've that's why I said I'm not sure, because I'm not into this. I'm not an engineer in that space, so I was wondering if because I've seen that it can code, but it makes sense that of course it's almost different type of technology.
I mean, just to be clear, underneath the hood, obviously everything is code.
Even neural of course,
are all code based, but it's not doing it in the. That's that software 1.0 versus software 2.0 thing. Software 1.0 is what you think of when you think of coding, all of the lines of Python or C or whatever it is, and a bunch of loops and a bunch of if-then statements and branching. And that's what Scott was saying. And then you have to put in your human knowledge and saying, like, in order to pick something up, there are these steps. And so those are heuristics. You're saying, like, this is what I know as a person, and I have to feed that in. That's really cumbersome in a complex object. And so the much nicer situation is to be able to just say, here's a neural network architecture with a bunch of weights, refine those weights until you understand how to do it. So that's the same way a human learns, right? When you're a baby, you see your little baby like dropping a ball, and it's so annoying as a parent because you have to keep picking it up and giving it back to them, right? But they do that because that's how their neural networks are training. That's how we figure out what gravity is, how to walk, how interactions happen, with physical objects, and of course with other humans and stuff too. So we're basically moving from a very, very restrictive, syntactically limited sort of situation with software 1.0 to more like the way biological entities learn. We figure it out because we experience it over and over and over again, and so we teach ourselves how to do it.
Okay. Yeah, pretty interesting.
Yeah. So let me phrase it this way for you, Young. So when this bottle is in front of you, and I'll try to get it into frame, and you want to grab that thing, there's a way we just kind of do it. And then there's a way that we would do it with traditional 1.0 programming techniques for any sort of mechanism or robot. So the first thing is, like, if I had a camera system, I would identify the object, and then at some point I have to identify maybe where the centroid is. So you do some sort of calculation to figure where that is. And then I would figure out where the Cartesian location is of that with respect to my body. And then from that, I choose which hand. I know it's going to be this hand over here. So I know the lengths of all my arms and the joint angles are in there. And I calculate the inverse kinematics and then use that to now come up with a trajectory to get over there. And so then I will then start initiating the control system to start moving all those motors to get them there. I coordinate them all together, make sure my hand is in like the open grasp condition to get over. Oh, and then I have like a tool point offset. So this is like a fictitious point kind of off my palm where I want that to match the centroid of this. So I kind of come over and do that, and I do those calculations. So that's what we're doing on the computer. Are you doing that? Are you doing calculus in your head and Newtonian physics and everything else? No, you're just there. You don't even think about that stuff. And so this is the difference, is that today, the way we have to solve it is we go back to math, because we believe math is this description of the universe, and that we use that because it does a very good job of being able to allow us to predict and control things. But the reality is no one is doing calculus in their head. They just get this innate feel and sense. And so the neural network eventually is just going to say, I just know how to do it. I'm not calculating centroids or anything else. And I could also tell that, just by quickly glancing at the bottle and sort of where the height of it is, I might choose to grab it a little bit lower, whereas if it was full, I might grab it in the middle, just because I can sense that. But I don't know exactly where it is, but I know where it is.
Okay, interesting. Yeah, maybe a lack of knowledge was was my problem there.
No, that was actually a good question, though, because I think a lot of people don't understand. This goes far beyond Tesla, actually. This is a hugely important thing for people to understand, is that we are, from the 1940s on, we've had one paradigm. No, that's not true, because we've had neural networks and stuff as far back as the 1950s. But the primary focus of computation for 80 years, something along those lines, has been doing it a very particular way, and it's a very limited way, and you spend years in college or at a job or something learning how to do it so that you talk to a computer the way a computer wants to hear it. We're flipping this all now. We're going to make the computer talk to us the way we want to talk. So that's the whole, the flip of this all. And it's going to make things like robotics and stuff actually workable. They just have not been workable because a complex system every time, I think it's, is it exponential? Like when you add more joints, like every single degree of freedom, you exponentially increase the complexity of the calculation. And a human body or a robot has a lot of degrees of freedom. And so it becomes exponentially complex to calculate everything. And so that's why robots look ridiculous. They're like, and they barely move and they make mistakes. And what we're going to see with neural networks is they're not there yet, but that's what everybody, not just Tesla, but a lot of people that are working in this area are working towards this. They are going to be very much more like a human being. They're going to look beautiful in a way when they work.
Wow. So. Awesome. That's also a good transition now to the end of the episode, because I think this is the core topic on this topic of the AG, to reach AGI and everything. Like, it's everything lumped together that we've talked about. Like, it's vision, it's the voxel size of going faster, going slower. Tesla is in the position to have like the car business, they have the robotics business, and then these two parts alone are very interesting and capable, and they're gonna shift everything. For example, things that Tesla Bot learns will be coming back to FSD, and things that are developments that are happening in FSD will help the Tesla Bot understand the world better. And also we have language models now, and with the acquisition of Twitter, maybe we have something in the direction of a language model forming now at Tesla, more or less. I don't know. We're gonna see that. So very interesting stuff. Everything lumped together seems like an interesting future again. Maybe we can talk now for the end. Just your thoughts, brief statement on your thoughts of the future of Tesla Bot. Where do we use Tesla Bot? Because I assume something, but maybe you want to think where's the use case of the Tesla Bot besides the factories? I mean, we can look much more in the future. Yeah.
Okay, so we know the factories. We've talked about that ad nauseum, and a lot of others, that's the natural place to begin. And then when you start going outside of it, well, one of the first ones right there is the superchargers. It's like, well, go ahead and put there. That's kind of natural. So there will be a lot of situations like that Tesla Bot can help out. The other thing we're wondering if this was a bit of an Easter egg is that when the Tesla Bots first come out inside that service bay area where we see the Cybertruck, and the technician is sitting down there, and I just always kind of joke that he doesn't care. I mean, it's like, they're coming in again. It's like he's seen it every day. It's not a new thing for him. It's almost like it's a distraction. But there was one other Tesla Bot over there next to the tool caddy. You're thinking, well, what's it there for? Because it seemed like it really was kind of tight in that corner, not part of whatever would be the line dancing or everything they're getting ready to prepare. And one thought is that they may be having the Tesla Bots going around these different areas, getting used to people. They're training them on the fact that there are people around and keeping a safe distance, and becoming acclimated to the fact that you are now going to be in an environment with people, what you have to do to make sure you don't do something wrong. That, the little brother, and I was the little brother who was always getting in the way. It's like, move out of the way. So it may be that there's things like that. You're going to start seeing more of it. And of course, what would be a good application for that? Well, a lot of us are sitting down there working on something like, grab me a spanner, or grab me a screwdriver. Go ahead and get that. I need an 8-inch socket or no, an 8mm socket. Go ahead and get that for me. And so rather than him having to do it, maybe that's something the Tesla Bot starts to learn in little situations like that, to get ready for full deployment. John, you probably have some ideas as well. I'll let you go ahead, because I think it helps a lot with AGI as well.
Yeah. In a weird way, I think eventually the question is going to be more where Tesla Bot will not be needed. I think honestly, there is a sense in which, and maybe they'll have to change the form factor eventually, and probably another company will do this, not Tesla, but we'll have robot pets. Your Tesla Bot will be a nanny for your children. it eventually could become a teacher of sorts. I don't know. It's a terrible statement on humanity, but we're busy as parents, and this is kind of weird. And I don't know whether this is a good thing or a bad thing, but what if you did have this full-time Tesla bot that was just for your child, and it was there all the time for it, and it took care of it, and if it wanted to go play baseball in the yard, it would go out and play catch with it. It wouldn't say, I'm too busy, I'm working, or I'm making dinner, or maybe it would make dinner for you, so you would have a chance to go play with your child. But there's the use cases. I think that's why Elon said they could have 10 billion of these things eventually. Now, that's not, again, that Tesla's going to make 10 billion of them, but that's the overall market for it. It's more than the human population of these robots, because I think that people, once they have access to this, just look at things like diffusion models with generating images. That came out a couple of years ago, not even maybe 2 years ago, like in a real way. And Mid-Journey only started just over 1 year ago, and it was terrible at the time. But with the effort and the involvement of humans, there's a bootstrapping aspect to it. So every time you have more Tesla bots out there, or diffusion models, or whatever it is, and people use them and they get excited, they find use cases that people hadn't thought about before. And then it gets trained and it learns how to do that use case. And then it can do something else. And so we're going to see this sort of like increase in something like Tesla bots capabilities radically over time.
I think I'm not sure you would say it's a nanny. You might use the term a governess.
There we go.
And because it's a little bit more highfalutin as far as what's going on. And actually the reason I say that is, I mean, the ultimate governess is Mary Poppins. So it'll be more than just sort of making sure your kids don't get into trouble, but probably getting them into trouble. Because remember, Mary Poppins was going off on all these field trips everywhere with the wild imagination and everything. That might be what Optimus is really going to do, is that be more than just watching over the kids, but really entertaining them, engaging them, making them do a lot more things that, we as parents, we try, but sometimes we're just too exhausted. It's like, I'd love to go out in the yard and play, but I've got all these other emails I've got to get to, or this or that, or you're just wiped out. Optimus will never be tired. And so when you come home, the kids will be absolutely exhausted because Optimus has been having to run around the yard, and they'll be like, "Oh, Dad, can I go to bed early tonight?" And you're like, yes, you can.
Awesome. And then have Optimus whip up a nice romantic dinner for you and your wife.
Yeah, exactly.
Yes. I think for me this sounds a little bit. I mean, I get what you mean. If like Optimus is very improved, like down the line, if give them more decades of working on this thing, the moveset will change. It will become more fluid in the movements. The robotics will get better as well in that time frame. It sounds a little bit dystopian to me a little bit, but I get what you mean. I also recently became a father, so I know the exhaustion level. I just had one child right now, but sometimes I really would love that Optimus could play with my kid or something. But what I was hinting at a little bit, for me at least, is what I find very interesting is sending rockets to Mars and just deploying Tesla bots to do some groundwork before the humans come. This is even medium term or something, you could say. It's not too far-fetched. I mean, okay, the gravity might be a little bit an issue or a little bit different. Or is the gravity at Mars how much?
Less. It's less. It's like
one. It's a little bit less.
It's one.
Yeah, it's exactly. So it has to adapt, but no problem there. They could adjust it, but something like that is very interesting. Where in conditions where it's dangerous for human to operate in. Yeah, that's. I mean, it's this alone is.
I will suggest that they will probably put Optimus on the moon first, because it's
of course,
so much closer, and also gives you a chance to deal with lower gravity situations and radiation and things like that to try to harden it. So, but yeah, I agree with you. It's why send us poor fragile human beings to a place that we haven't gotten nicely, crafted for our living environment.
And also speaking of fragility, is that when you send something all the way to Mars, it breaks down. It's very hard to repair. So a lot of what they want to do in Optimus is minimize the number of components that can potentially fail along the way. And so it's like, why no movement in the neck? you don't really need it. And that's just, something that could
Point
fail.
of failure.
So simplify it. So again, they're trying to reduce the number of joints that they need to have for a lot of these operations, which maybe that's why the feet are going to be the way they are. And then the other will be interesting to see, because it looks like it's pretty easy to assemble. I assume it would be fairly easy to repair as well. And then to get it in the state that not only can Optimus assemble another Optimus, but be able to repair another Optimus. So keep your part counts down, because then that's the old adage, keep it simple, stupid. So that keeps it down. And then also, Murphy's Law, which everyone thinks is a joke, but engineers actually take seriously, that, anything that can go wrong will go wrong. And that's the reality, is that every single motor, one of them is going to fail at some point. So the fewer points of failure you have, the better off you are.
That's true.
But you also have an advantage with that, because especially on something like a Starship, I don't even know how many hundreds of Tesla bots you could put on there. So if you have a 50% failure rate, that's okay. You'll still have 50%. You could have 500 or more, because you don't have to have living space. As a human being has to have space to move around and breathe. You could just stack these up like wood. They could just be stacked up inside this thing, and then you just kind of spit them out like a Pez dispenser.
And we know how they're going to be lifted out. Is that there was an image in there. You have to look kind of closely, but anyone who looks at that video where the engineers put his hands up, look very closely at the head of the Tesla bot, and you'll notice that the top of the head is removed. And there's a lanyard in there. So that's the suspension points now for it. And that's what it makes sense that you can use that now, because you don't have a joint in the neck to worry about. So that is connected directly to the torso. Whereas before, you were always seeing that the attachment points would be outside on the back of the torso or somewhere else. So now they are able to do it, let's say, very different point of contact in suspension. And again, maybe that's what they're thinking about. It's like, oh, okay, we're going to have all these Tesla bots in the Starship. How are we going to mount them in there? What's the best way to get them in and out?
And they mount them. Pretty much every Tesla bot in this video does not have a top of its head anymore.
Exactly.
Yes. Yes. They have them, but they're removed because they're constantly having to deploy them and move them around. Right. And then the others that are doing the line dancing, it looks like they have a really funny haircut. You'll see the top of the scalp is kind of missing there.
Yeah, that makes sense. So this is their mounting point.
Yeah, maybe there you can definitely see it.
Yeah. Okay.
And there.
Over there as well. Yeah, maybe they're gonna have a small door that opens up automatically. They can just plug it in and then just stack those robots with a crane.
It's actually like a lot of the movies that science fiction movies, they have them all hanging like on things that kind of like drop them out. It'll be just like that. They'll get close and they'll just drop them right out. They'll just go drop out.
So
their head.
Absolutely interesting future we are heading, especially with Tesla. What really makes you dream about the future more, and we all hope that Tesla will accelerate even more to reach this. So thank you very much for being on this episode. I really enjoyed it, your view and everything. I've learned a lot, and also the audience, I assume. So maybe for the end of the video, you can talk about your projects that you're working on, something you want to highlight, or plug your merch store of Dr. Know-It-All. I'm going to link it in the video down below until I have my merch store. So
wow.
What's on your mind?
Oh gosh, I don't even know what to say about that. I'm sort of overwhelmed with what's going on right now, that I think both in a research sense. So I've got some university research stuff going on, and also company research stuff going on, and it all it's becoming much more involved in large language models than it was. I would never have imagined that 6 or 7 months ago, before ChatGPT came out. But now it really is pretty critical to make sure that research is focused in that area. So there you go. That's my nutshell version.
And you, Scott?
I am working on a lot of interesting projects. Unfortunately, I can't say much more than that. They're kind of interesting, and that fortunately some of them have something to do with like renewable energies, EVs, and stuff like that. So that's about as far as I can go.
Okay,
but it's just kind of nice. All I can say is that before we used to have a lot of projects that were not in that area. And now a lot of them are coming from that area. So that's
that's cool.
Also my feedback loop to notice that, well, it's kind of part of the due diligence. Like, well, wait a minute, if we're getting customers that are in that space, it must mean there is serious investment going on in that. So that's all I can say.
Yeah. But thank you very much. Please follow also Scott on Twitter and Dr. Know-it-all on Twitter. And we are looking forward for your interview, Dr. Know-it-all, or John, for your great interview with Elon Musk. Will it be in person or not? It will be on Twitter Spaces, right? At first.
I'm trying to get it in person. So yeah,
of course.
See. Yeah, of course. I mean, if it has to be remote,
fingers crossed.
Remote, that's fine, but yeah, if it can be in person, I would love it to be in person. So yes, cool.
Okay, so yeah, we're all gonna cross the fingers that it works, and we're gonna look forward to see that. And for the whole audience or the rest of the audience, the last thing we have to say now is goodbye, everybody.
Yep.
Wasn't this episode awesome? Let's accelerate the pace of innovation by subscribing to Tesla Fix. It is my absolute favorite channel on the whole interwebs.